Grade 8s. So today we will continue with solving inequalities part 2, which is to do with multiplying and dividing inequalities. Now, yesterday's lesson, I talked about adding and subtracting inequalities. And so when you add to one side, you add the same to the other side, and then you solve it just like you do with normal equations. Now let's look at a example of an inequality. Let's say that 5, whoops, let me use black. Let's say that 5 is less than 10, and this inequality is true. 5 is indeed less than 10. Now, what I would do to this one, today we're going to look at multiplying. So what will happen if I multiply these inequalities bigger? Let's say I multiply 2 to both sides. And so you would see after we multiply 2 to both sides, 5 times 2 will be 10. And then 10 times 2 will be 20. And so our inequality is still the same. It still stays 10 is less than 20. Is that true? Certainly, that is definitely still true. What if I multiply even bigger? Let's say I want to do times by 5 this time, times 5. And so the left side will be 10 times 5, which is 50. The right side will be 20 times 5, which is 100. And 50 is certainly less than 100, so it is all correct. There's nothing different about this. Now, what if we look at dividing? So this part was multiplying bigger, multiplying. And what about dividing? And so with dividing, I'm not going to use the divide symbol, but instead I'm just going to multiply it by a fraction, which is the same as dividing. And so let's start with an inequality. Let's say we're still doing 10 over 20, for example, 10 over 20. And then 10 is less than, sorry, not 10 over 20. 10 is less than 20. So that's a true statement. So what happens if we're going to divide both sides by 2? Divide by 2 means the same as times half. So if I do times half and times half, what would happen? Over here, 10 times half will be 5, or 10 divided by 2. And then 20 divided by 2 will be 10. And then 5 is less than 10. Is that true? Yes, that is still true. I can even divide by 5. Let's see what happens if I divide by 5. That's going to be multiplied by 1 over 5 times 1 over 5. And so you can see the left side, 5 divided by 5 is 1. 10 divided by 5 is 2. 1 is less than 2. Is that true? That is certainly still true. So in terms of multiplying and dividing, we just multiply to both sides. Our inequality still stays the same. Now, there's one different thing that I want to talk about. That is, what if we multiply and divide by a negative number? So over here, I'm going to make a new section, multiplying slash dividing by a negative number. So let's start off with the same example. Let's say that 5 is less than 10. That is certainly true. We're starting off with real numbers so that we can actually see the inequality. And then let's say that I want to multiply both sides by negative 2. So what happens if I multiply by negative 2? Multiply by negative 2 times negative 2 in a bracket times negative 2 in a bracket. And so 5 times negative 2 will become negative 10. And then 10 times negative 2 will become negative 20. Now, if we're going to compare negative 10 and negative 20, which one is less? Well, is negative 20 less than negative 10? Yes, actually, negative 20 is less than negative 10. That means that negative 10 is now greater than negative 20. And so if you're multiplying and dividing by a negative number, the inequality would actually swap. And so keep that in mind, when multiplying, I'll just use times, when multiplying a negative number to both sides, the inequality will swap. And so from less than will turn into greater than. So for example, less than will turn into greater than. And then also if we have greater than, will turn into less than. If you have less than or equal to, it would turn into greater than or equal to, and so on. Let's look at another one, another example. This time let's multiply by a fraction and let's see what will happen. Let's say that we have 4 is greater than 2. Okay, 4 is greater than 2. And so what will happen if we multiply negative half to both sides? What happens if we multiply both sides to negative half? So first of all, if we multiply by a negative number, it turns into a negative number. And then you multiply it by half as well. And so 4 times half is 2. Negative of 2 will be the result. And so this will now become negative 2. And then what about 2? 2 times half is 1. And then you also need to change it into negative. So that's going to be negative 1. And so with negative 2 and negative 1, which one is greater or which one is less? Well, negative 2 will be less than negative 1 because it's more negative. And so you can see that we have indeed swapped the inequality. From 4 is greater than 2 turns into negative 2 is less than negative 1. Okay, so when it comes to multiplying and dividing by a negative number, we need to swap the inequality. So let's go straight into an example of solving inequalities. Solving inequalities by multiplying and dividing. So let's say we have an example. 3x is less than 12. Okay, so we have 3x is less than 12. We know that 3 times x is less than 12. So if I'm just going to substitute in any number, excuse me, I'm sorry. If we're going to substitute any number, let's say, let me put in x is equal to 4 and just test it out. 3 times 4 is 12. Is 12 less than 12? No, 12 is not less than 12. 12 is equal to 12. And so 4 does not work. What about 5? If I put in 5, 3 times 5 will be 15. 15 will be greater than 12. And so that doesn't fulfill the statement of 3x is less than 12. Let me try in 3. So 3 times 3 is 9, and 9 is less than 12. And so I know that for x can take the value of 3, it can take the value of 2, it can take the value of 1, and so on. Because I know that any number that I put in x over here that is less than 4 should be sufficient. And so how do we do this? Well, this time we're going to divide both sides in order to isolate x. Okay, so we do the same as equations. We want to isolate x. Want to isolate x by dividing by the coefficient of x. Okay, so want to isolate x by dividing both sides by the coefficient of x, which happens to be 3. And so we're going to divide both sides by 3 over here. And just like the above example, if we multiply and divide by a number, we do it to both sides, and our inequality would stay the same. It would still, if it's less than, it will stay less than. And so what happens here is that 3 divided by 3, we will have just x over here. 12 divided by 3, our inequality stays the same. And 12 divided by 3 is 4. And so now we have x is less than 4. And then if we're going to graph this in a number line, let's just put 4 in the middle. 4, 5, 6, and then 4, 3, 2. And then we're going to have a less than. Less than means it's going to be a hollow dot because it's not including 4. And then I'm going to point to the left side because we want all the values that are left of 4, which is less than 4. So that's how we graph this and solve this. Now let's do another example. Let's say that this time we have um, 10 is greater than negative 5x, for example. So this time you can see that we have a negative number, negative 5x. And so first of all, we got to think about what we're isolating. We want to isolate x. That means we want to get rid of the coefficient that is in front of x, which is the negative 5. So keep in mind the coefficient, okay, that will be the coefficient of x. Coefficient of x is negative 5 over here, which means in order to get rid of it, we want to divide both sides by negative 5 in order to get rid of the negative 5. And so we also have to remember when dividing a negative number, we need to swap the inequalities. And also remember when dividing by negative number, need to swap the inequality. So let's go ahead and do this. And so when we're dividing both sides by 5, let me just show my working out. So first of all, over here, if we're dividing by a negative number, so I need to show all of my working out at the same step because we're doing two things at the same time actually. We're dividing both sides by a negative number, which means we're going to swap the inequality, and then we have our negative 5x divided by negative 5, and then we have our 10 over here divided by negative 5. And so once we have the divide to both sides, the negative 5 and the negative 5 will actually cancel out. And so our x is actually greater than 10 divided by negative 5 will be negative 2. And so we have swapped the inequality from 10 is greater than negative 5x into negative 2 is less than x. And then the last step is we're just going to mirror everything to put x back into the left side because we're used to x being in the left side. So if x is greater than negative 2, what's a number that's greater than negative 2? 2 is greater than negative 2. And so if I want to put it back into the other side, well, yeah, negative 2 is less than 2. Well, sorry, I said it the other way around. So negative 2 was less than 2. And so if I want to say 2 is what than negative 2, 2 is greater than negative 2. So let's put it back. X is going to be greater than negative 2 this way. And so last thing we need to do is to graph this in a inequality into a number line. And so let me put negative 2 over here. We have negative 1, and then we have 0 and 1, and then we have negative 3, negative 4, and negative 5. Negative 2 less than, x is greater than negative 2. So again, we're going to put a hollow dot, and then greater than, so that's everything that is on the right side. So this way it is fulfilled. So let's do one example of a mixed operations for inequality. So before you go to do your homework, let me show one more example. And I do want us to do some examples together. So example of mixed operations for solving inequalities. Solving inequalities. And so let's say that we have, let's start off with a simple one. 2x plus 1 is less than or equal to 5. Okay, and so when we're doing this, the first thing we need to notice is we want to isolate x. We solve this similar to any normal equations. So solving inequalities would be fairly similar to solving equations. So I want to get rid of the constants first. I want to put everything on, all the x's on one side and all the numbers on the other side. And so I can see that there's a plus 1 with the 2x. And so I want to get rid of the plus 1. We want to put the plus 1 to the other side. So that turns into minus 1. So my first step will be 2x is less than or equal to 5 minus 1. So it turns from plus 1 to minus 1 when it's put into the other side. And so all I'm doing is adding and subtracting, so my inequality doesn't have to change. And then this turns into, I'm going to just do an extra step. 5 minus 1 is 4. And now what I want to do is I want to divide both sides by 2 because there's a 2 in front of the x. Or I can call it cross multiplication and put the 2 at the bottom. And so if we're multiplying and dividing by a positive number, our inequality doesn't change. And so my next step will be x is less than or equal to 4 divided by 2. And then 4 divided by 2 will be 2. So that means x is less than or equal to 2. And then we need to graph the solution as well. So if we're going to draw a number line, let's say that we have 0, 1, 2, 3, and then we have -1, -2, and -3. This time it is less than or equal to 2, which means that it's going to be a solid dot because it's less than or equal to, and it's less than 2, less than or equal to. So that means we're going to draw our arrow to the left because it's anything that is less than or equal to 2. So that's A. Now let's do one more together. I'm going to show you the answer straight away, and then afterwards I'm going to give you 3 other examples to do on your own. And so for B, let's say that we have 5 plus 2, 5 minus 3x is greater than or equal to 10. Or let's just say it's less than or equal to 20. Okay, so we have 5 minus 3x is greater than or equal to 20. Now, there are more than one ways of doing this. Okay, there are more than one way of doing this. You don't have to solve it by one particular way. I'm just going to tell you for now that there are 2 different ways that I'm going to show you how to do this. Now, the first way is I can see that there's a 5 and a 3x, and we want to put all the like terms together. And so I'm going to move the first way to do it. Okay, way 1 will be I'm going to move the 5 to the other side like this, and so that we have 3x on its own, -3x on its own, and then we have 20 minus 5. And so the next step will be -3x is greater than or equal to then 20 minus 5, because positive 5 moved to the other side is -5. And then that's going to be -3x is greater than or equal to 15. And then what we're going to do is we're going to move the 3x to the bottom by dividing both sides by -3. And so when we do this, x is now less than or equal to, because we're multiplying and dividing by a negative number, that's going to be 15 over -3. And so 15 divided by a negative number will be negative, and 15 divided by 3 will be 5, and so that will be -5 in the end. So like x is less than or equal to -5. So that's the first way of doing this. Now, there is a second way. Indeed, there is a second way. So let me just copy the question again. 5 minus 3x is greater than or equal to 20. Now, instead of moving the 5, because I don't like working with negative numbers, right? Negative numbers are just in general confusing. So what you could do is you can send the -3x to the other side. And so minus 3x, when you move it to the other side, will become plus 3x. And then we can also move the 20 back to this side. So it becomes 5 minus 20 is greater than or equal to 3x. Okay, so remember, adding and subtracting in inequalities doesn't change the inequality. So if it's greater than, it still remains greater than. So this time I'm just adding 3x to both sides so that my -3x would disappear from the left, and then we will have a plus 3x on the right side. And then 5 minus 20 will be -15 is greater than or equal to 3x. And then all I have to do is divide both sides by 3. I'm dividing by a positive number, so I don't need to change the inequality. And so we have -15 divided by 3 is greater than or equal to x. And so 15 divided by 3 will be 5. It's a negative number, so that's negative 5 is greater than or equal to x. And then our x is on the right side, so all I have to do is mirror the whole inequality so that x is now less than or equal to negative 5. Now, in the end, we will still end up with the same solution. X is less than or equal to negative 5, but the only difference is for the way on the left is I kept my x on the left side and I kept the negative number there, and the way on the right is I moved the negative 3x to the right side so it becomes positive 3x, and I don't have to change my inequality until the very end where I'm just presenting my solution. And so after that, we just have to also put it in a number line. So let's say that this is negative 5, negative 4, negative 3, negative 2, and that's negative 6. Oh, no, wrong way. Negative 5, the more left we go, the more negative it is, right? Negative 5, negative 6, negative 7, negative 8, and then we have negative 4 and negative 3. And so x is less than negative 5, less than or equal to, so it's a solid dot on the negative 5, and then there's going to be an arrow pointing to the left again. Okay, so I know I've been talking quite a lot. So what I want us to do before you actually do the homework on your own is let's do 3 other examples. So example, I did A and B by myself, and so for C, D, and E, I want you to do your own. So C, D, and E, and then afterwards I will go through the solutions for all of you. So let's say that we have 3 plus 6x is less than or equal to 21. And then for D, we have minus 2y minus 5 is greater than 15. And then for the last one, E, let's say that we have negative 7 minus 4x is less than or equal to 9. So what I want you to do is I want you to try and solve all 3 of these inequalities on your own first. Make sure you also graph the solution. So you want to solve and graph the inequalities. So do these 3 questions first. Pause the video. So I assume you have finished, you've done them. If you haven't, then please pause the video and do these 3 questions. I'm going to go through the answers now. So we have 3 plus 6x is less than or equal to 21. And so 6x is less than or equal to 21 minus 3, which is going to be 18. 6x is less than or equal to 18, which means that x is less than or equal to 18 divided by 6. And so 18 divided by 6 will be 3. So x is less than or equal to 3. And so once we graph this, 0, 1, 2, 3, 4, and we have negative 1 over here. Less than or equal to 3, it's a solid dot on the 3, and then we're going to do a arrow to the left. Now, D. Negative 2y minus 5 is greater than 15. As I said before, there are 2 ways of doing this. I'm going to show this one first with the way of the left way, and then for E, I'll do the right way. And so not the correct right way, as in like the left as in left side way and the right side way. So negative 2y, that stays the same. Negative 2y is greater than, when I move the negative 5 to the other side, it becomes plus 5. So it's going to be 15 plus 5. And so negative 2y is greater than 20. And then if I'm going to divide both sides by negative 2, I'm going to swap the inequality from greater than turns into less than, and then we have 20 over negative 2, and so y is less than negative 10. And so last we have to graph the inequality. Let's just say negative 10 is here, and then more negative, that's negative 11, that's negative 12, and then we have negative 9 and negative 8, and then it's less than, so not including 10, so it's a hollow dot, and then we draw a arrow to the left. All of the answers seems to be less than to the left. Let's see if it changes for the last question, E. So as I promised, I would do the right side way. So I would send our minus 4x to the other side, and then we would also send our 9 back to this side. And so we have negative 7, positive 9 turns into minus 9 is less than or equal to 4x. Because minus 4x, once you move to the other side, turns into plus 4x. And so negative 7 minus 9 will be negative 16 is less than or equal to 4x. And then I'm going to divide both sides by 4. And so negative 16 over 4 is less than or equal to x. And so negative 4 is less than or equal to x. And then last, what I'm going to do is I'm just going to swap the left and the right. Not swap. Just mirror the whole inequality because I want x at the left. And so if x, you can see if you read it from this way back, from right to left, it's actually just x is greater than or equal to negative 4. So let's just write it this way. X is greater than or equal to negative 4. And then let's graph it. This time it's a greater than. So we have, let's put negative 4 over here. And then we have negative 5, negative 6, and then we have negative 3, negative 2. And so greater than or equal to, it's a solid dot at negative 4, and then our arrow goes to the right. So that is it for today's lesson. Your homework is to complete these questions over here. So it's exercise 7.6. It's still the same exercise. And then questions 15 to 22. So 15, 16, 17, 18, 19, 20, 21, 22, 8 questions. And then 31 and then 33 to 36. I know it's quite a bit, but we should be able to finish them within 20 to 30 minutes if you are focused. So thank you for watching. Please also tell your classmates to watch today's lesson if you know that they haven't done it. So please spread the word among your grade 8 classmates, 8C and 8D, just 8C and 8D, that you have a video lesson to watch, and there is also homework to complete. I have posted the homework page for both part 1 and part 2 on the same page. So once you've done all the homework, please take a picture of your homework and post it onto the same page, the part 1 and part 2 together. Okay, so that's it for today's lesson. I will see you guys in our next Zoom live lesson.